Okay, please turn to question number 40 under chapter 17 in your study guide. We are going to talk about equilibrium and Le Chatelier's principle. So first off, there are reactions that are reversible. So for example, okay, we will take this equation for example. There are three things that affect a system that is at equilibrium. First off, equilibrium means that it is a reversible reaction. So we can go in the forward direction, so meaning reactants form products, that's called the forward direction, or favor products. What this means is that the reaction will proceed in the forward direction to form more products. The terminology is called favor the products. Now, if this equilibrium system goes in the other direction, this is called the reverse reaction or favor reactants. Okay, so that's just some terminology. So you could say like equilibrium shifts to the right. Okay, that's another thing. This would be a shift right. And this is called a shift. Okay, so there's a lot of different terminology that goes along with equilibrium, but what equilibrium is, it is a reaction that's reversible. So in some cases, you could have the hydrogen reacting with nitrogen to produce this ammonia. Or you could also have this reverse reaction where ammonia decomposes into nitrogen and hydrogen. So this is called the forward reaction. This is called the reverse reaction. If equilibrium is favoring the products, it's called a shift to the right. And if it's favoring the reactants, it's called a shift to the left. So what sorts of things can disrupt a system that has already reached equilibrium? A system that's already reached equilibrium, the concentrations of reactants and products will not change unless you add something in or put a stress on the system that changes the equilibrium system as established. So what does that mean? Well, the three things that affect equilibrium are number one, concentration. Temperature. And pressure. Okay, so those are the three changes that can affect a system that is already at equilibrium and cause a shift towards either the reactants or products. So let's go ahead and look at each one of these separately and talk about what the effect of increasing concentration or decreasing concentration of reactants and products, and same thing with temperature and pressure. So we'll go through concentration first. So for concentration, if I were to increase the concentration, if I were to increase the concentration of this reactant, so I increase the concentration of hydrogen and disrupt the system that's at equilibrium, then the system will react in order to counteract that increase. So to counteract the increase, equilibrium is going to shift right. And when it shifts right, that consumes that additional hydrogen that was added because this hydrogen is reacting with this nitrogen to produce this ammonia, causes a shift to the right, and that consumes that additional hydrogen in reestablishing the equilibrium. Same thing would happen if I increase the nitrogen. So if I increase the concentration of a reactant, equilibrium shifts to the right. Now, the opposite happens if I increase the concentration of a product. So let's say I increase the concentration of ammonia, equilibrium is going to shift to the left in order to counteract that increase in ammonia. So that ammonia will then decompose into nitrogen and hydrogen, and equilibrium will be reestablished. All right, so that is concentration. Now, another component or another thing they can ask is, well, what if I take away hydrogen or I take away nitrogen? I remove it from the system. That will cause a shift to the left as well, because you will want to reestablish the concentration of this nitrogen and hydrogen by shifting to the left. If I decrease the concentration of ammonia, it's going to shift to the right to reestablish the concentration of ammonia. So it's kind of like an opposite type thing. What happens to one side causes a shift to the other side to counteract it. So another component, or the second thing we talked about, is temperature. Okay, so this is talking about temperature. Now, temperature depends on if it's endo or exothermic. This is an exothermic reaction because heat is on the product side. So this is exothermic. If heat were written on the reactant side, it would be an endothermic reaction. So since heat is written on the product side, we treat it like a product. So if I were to increase temperature, so if temperature were to go up, equilibrium would shift to the left. Just like if I increase the concentration of this, equilibrium would shift to the left. If I decrease temperature or take heat away, it's like removing a product. So it would shift right to counteract that effect, and that would serve to increase the heat. So heat depends on if it's endo or exothermic. Now, if heat was on the reactant side, you would treat it as a reactant, and it would have the same effect as if you were increasing the concentration of hydrogen or nitrogen, but now we're looking at a temperature increase or decrease. Okay, the final is pressure. So pressure is based off of the moles of gas. So if we increase pressure, so if we were to increase pressure, the more moles of gas there are present, the greater the pressure. So if we increase pressure, we want to reestablish equilibrium again. We need to shift to the side with the fewest number of moles. So we need to count the coefficients. On the reactant side, we have 3 plus 1, we have 4 moles. Okay? And on the product side, we have 2. So in this case, if I were to increase pressure, equilibrium would shift to the right because it shifts to the side with the fewest number of moles. A decrease in pressure is going to have the same effect, but it's going to shift to the side with greatest number of moles. Okay, So if we decrease pressure, it's going to shift to the side with the greatest number of moles, which would be to the left in this particular equation. So pressure, the effects of pressure are different for each type of equation because you have to count the number of moles of gas on either side. And by the way, they have to be gases in order to actually affect the equilibrium of the system. So if we look at question number 43, it's pertaining to this particular problem that we've just been looking at. So here's the equation for question number 43. And then it asks us on question number 44 to use the above equation to answer the following. So we're doing question number 44. Letter A, how does an increase in pressure affect this reaction? Okay, well that will affect this reaction by shifting to the right. Okay, so equilibrium will shift to the right because increasing pressure, it's going to shift to the side with the fewest number of moles, which is the product side. B, if the concentration of hydrogen is increased, the reaction shifts in which direction? Well, if I increase hydrogen, it is going to shift right. Okay, because if I increase a reactant to counteract that effect, it's going to shift to the other side, to the product side. And letter C, decrease in temperature. So I'm removing heat from the product side, which is going to cause a shift in equilibrium to the right to reestablish that heat. So this is a shift right as well. So for equilibrium, if you can tell which direction that the reaction will shift in based off of concentration, pressure, and temperature, then you will be able to answer the questions on the final exam that pertain to this.